Hello everyone and welcome back. This is Mr. Keeney and we are continuing our Unit 3 notes today. We are actually moving out of the world of parallelograms, but we are staying in the world of quadrilaterals, which, just a reminder, Unit 3 is all about quadrilaterals and actually just polygons in general. Today, if we're not talking about parallelograms, but still quadrilaterals, we're going to talk about two of the more well-known that fit in that category, which is trapezoid and kites. So I'm going to get started just right away with trapezoid. This is a shape, again, something that you've probably seen when you were younger taking math classes. And this is really what kind of makes it similar and different. The similarities to it with parallelograms is that it is a quadrilateral. It is a polygon with four sides. But this is the main difference. It's a quadrilateral with one, I'm going to underline that, that's big, one pair of opposite sides parallel. So as you're getting this down with me, thinking about what makes this different is that word one. If we were talking about parallelogram, we would say both pairs of opposite sides are parallel. In a trapezoid, if I want to mark them here, we can see that AB and CD or DC are going to be parallel to each other. And there's specific type of sides that we call these. Not only are they the parallel sides, but we call them the bases. The two parallel sides are called the bases. And then in a trapezoid, we have a name for those other two sides that hold the bases together, which are the legs. So we have the base, and it kind of makes sense if you were to think like a structure. The leg is holding the legs is holding the bases together. And then we have certain kind of base angles. We have pairs of base angles. So angle A and angle B are base angles with each other. And the reason why they're base angles with each other is because when I look at A and B, they are a part of the same base. So we would say A and B, they're base angles with each other, just like we could say angles D and C are base angles with each other. So they're both, I guess when you think of this, all four angles in a trapezoid are base angles, but it depends on what pair they are. So C and D are part of that bottom base, A and B are part of that top base. So base angles, which will become a more important topic with this next trapezoid, which is just a special trapezoid. Actually, that's how the definition starts. It is a trapezoid. So an isosceles trapezoid is a trapezoid. That means it has one pair of opposite sides that are parallel, and we can see that here with these arrows that we're given, that we still only have one pair. And you can probably see what the main difference is. It's a trapezoid with congruent legs. So the legs are congruent, which in our head we think isosceles triangle has two congruent sides. This one is an isosceles trapezoid, has two congruent legs. Another thing about this one, let me get rid of that mark, is that base angles will be congruent, which actually I'm kind of jumping ahead of myself. I'm getting excited because I'm looking now at this theorem, and that's exactly what it's saying here. If we have an isosceles trapezoid, if a trapezoid is isosceles, then each pair of base angles is congruent. They are the same as each other, which you can see down here in these pictures. B and C will be congruent to each other, and A and D will be congruent to each other. They are all a part of, B and C are part of the same base, A and D are part of the same base. So A and D are congruent, and then B and C are congruent. And that's because, again, this is an isosceles trapezoid. It has these congruent legs. So we can actually reverse this as well. If a trapezoid, so let's say we get this picture, or we have this scenario. If we have a trapezoid and we know a pair of base angles are congruent, then we can conclude it is an isosceles trapezoid. So it goes both ways. These two theorems are very alike. You can know either pair of information. So this one's saying if we know the angles are congruent, then the trapezoid is isosceles. And then we got one other thing here about trapezoid, isosceles trapezoid. So if the trapezoid is isosceles, then the diagonals are congruent. It doesn't mean they bisect each other. It just means they're congruent. So in this picture, notice that we don't necessarily have the tick marks there, but what we do know is that AC will be congruent to BD, which is AC and BD. I'm not going to put the tick marks there because it might confuse you with which parts but we know that those diagonals are the same length. So we're going to do an example real quick dealing with a trapezoid, actually an isosceles trapezoid it looks like, because I do have these tick marks here. Let's read what it has for us. Kitchen, a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. They want us to find the measure of angle N, L, and M. So when we talk about this, we want to make sure that we have this isosceles triangle, which means base angles will be congruent. That is our ticket here. So isosceles means that base angles congruent. So when I look at K, which is 50 degrees, that means its base angle would also be 50 degrees. So the measure of angle N would equal 50 degrees. And here's another thing that we can talk about. When I'm looking at L, and I'll give it 2 tick marks, because right now we know these will be the same thing. When looking at this 50-degree angle and then looking at this angle L here, they are consecutive interior angles. They are on the inside of the two bases, and they are on the same side of the parallel line. So what we are going to do with these two are supplementary. They must add up to equal 180 degrees. So I'm going to take 180 and subtract what K is, which is 50, and I will get 130. So the measure of angle L has to be 130, because when I look at 130 and 50, that equals 180. And then if L is 130, its base angle would have to be the same thing, because this is an isosceles trapezoid. So there are our angle measurements for those four for our kitchen cupboard. All right, so that kind of wraps up trapezoids for these notes. We're now going to shift to kite. Now, kite, again, we're still in the world of quadrilaterals. So it is a quadrilateral with both pairs of consecutive sides congruent. Consecutive congruent. So when we take a look at this here, you'll notice that these two sides next to each other, that is one pair, and they are congruent. And we can look at the other two here. They are congruent. Now, the most iconic thing about a kite, if you ever were to build a kite as a kid, the first thing you do is get 2 sticks, 2 rulers, 2 pencils. I don't know what you guys are using, but you would make a cross. Now, when we make that cross, it would make a perpendicular or a 90-degree angle. So when we look at this kite shape here, the same thing is with our geometric figure. We have this 90-degree angle. So we say if the quadrilateral is a kite, then the diagonals are perpendicular, and I'll even write that out for you. They make a 90-degree angle. So if this is a kite, then what we must know is that those diagonals CA and BD are perpendicular. All right, so there is another kind of thing that we would know as well here. I'm trying to keep it in the same picture. If a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So looking at this picture, how I always imagined it was in this, A would be congruent to C, and B and D would not be. And here's why. When we look at this picture up here, look at angle C. It is formed by the sides that have 1 tick mark and 2 tick marks, just like its opposite angle A, 1 tick mark and 2 tick marks. So when I look at these, I know that they're going to be congruent. When I look at angle B here, it is formed by 1 tick mark, 1 tick mark sides, and D is not formed by the same 2 sides. So it is completely different than the other 3. So that's how I remember it is look at the 2 angles that are formed by the same tick mark side. So if we look at C and we look at A, we're going to see that they're both formed by the 1 tick mark and 2 tick mark sides. All right, and so we're going to do just a quick example dealing with a kite here. It says find the measure of angle T in the kite shown on the right. So this one, we want to make sure that we write other things we know. So for like T here, actually let's start even simpler than that. We'll just put an X, because that's our unknown. That's what we're going to try to find. Now you'll look here, I was just talking about this. We have the 1 tick mark and we have the 2 tick mark. And if I look at angle T, it is made up of the 1 tick mark and 2 tick mark side, just like R is, 1 tick mark and 2 tick mark. So this is also going to be X. And I want you to recall that if I wanted to find what all four of those would equal, we can still do this. We can do 180 times n minus 2. This is going back to 8.1. N equals 4 because this is a quadrilateral. We got four sides. So I'm going to figure out what all these angles add up to equal. So I'm going to put 4 into n, and we do 180 times 2, which is 360. Now, what's important about 360? If I were to take x plus 70 plus 88, if I add all those four angles up, remember, that has to be equal to the 180 times n minus 2, which we just said was 360. So now here's an equation we can use to solve for x. We got like terms that we're going to deal with first. X and x make 2x. 70 and 88 make 158. I'll bring down the equal sign and the 360. I'm going to take away the 158 now. Cancel that out, bring down the 2x and the equal sign. 360 minus 158 is, oops, I didn't mean 1, 202, sorry about that. And then we will divide by 2 to get x equals 101. So if I were looking at the measure of angle T, it is whatever x is, which is 101 degrees. All right, so there's an example for kites. So the two big things today, we talked about kites, trapezoids, two other special types of quadrilaterals, but they are not parallelograms. Please let me know if you guys have any questions, and I will talk to you guys.